Hello, this is a video for problem 2. Alright, well, if you watch video number 1, I sort of mentioned a joke. So, the answer is Yamaha ha 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 ha. Damn, that was so stupid. Anyway, I'm sorry, I'm just awkward. Alright, so on to number 2. So basically, so it's asking for pH and pOH of whatever it's given, acetic acid and ammonia. And I think you probably noticed that the Ka and the Kb are actually the same for acetic acid and ammonia. So that could tell us one thing, that whatever we calculate, doesn't matter if you start with acetic acid or ammonia, the pH of your acetic acid is going to be the same. Is going to be the same value as the pOH of your ammonia, which we'll see in a second. Alright, so first, whenever you determined, you need to determine H3O plus concentration of pH, you always have to do a skid chart. I have no idea, I don't know how to emphasize how important skid chart is. This is like your life. Your life depends on it. If you don't know how to do a skid chart, you need to learn how to do this, right now, in order to pass your test on Monday. Or pass my mock exam on Thursday, which I thought was going to be that hard, because I don't have time. I still haven't make it yet. And it's 7:30 at night, Wednesday night. Yeah, anyway, I procrastinate too much. Anyway, so you do a skid chart, and so it's given Ka of your acidic concentration, acidic acid. So K is 1.8 times 10 to the negative 5. So we know that Ka is pretty much just H3O plus equilibrium times CH3CO minus, which is your conjugated base for your acidic acid, over your initial, or your acid at equilibrium. So you just plug it in. And I can assume, so let's just assume that x is small, so 0.240 minus x, that's your initial concentration of acid. So we just assume that it didn't change much because it's a weak acid. So and then after I find x, I need to calculate the percent error. So which is gonna be H3O plus equilibrium over acid initial concentration times 100. So you'll be 0.00020785 divided by 0.240 when the answer is less than 5%. So the assumption it's okay. Okay, so now look at the highlighted part. So we know that x is just the H3O plus concentration. So we just know that that would be your H3O concentration, H3O plus concentration. So that would be 0.00020785. And the pH is negative log of that value, which is 2.68. And we also need to find pOH, right? So we know that the relationship between pH and pOH is that when you add them together, you get 14. So it's just pOH is 14 minus pH, which is 2.6. 14 minus 2.68 equals 11.318 pOH. And then, of course, from pOH, we could determine the OH concentration by taking 10 to the negative 11.318, which gives you 4.81 times 10 to the negative 12 mole per liter, which makes sense because that's acidic acid, and your concentration of your OH should be extremely low. Right? So now we'll move on to the next question. Okay, so I just did extra work just for you guys to see why I said that the pH for part A is the same value as pOH for part B. So we just have to do a skid chart again. So NH3, which is ammonia. Don't mistake ammonia with ammonium. Ammonium is that thing with the plus little thingy there. And NH3 is ammonia. Okay. So ammonia has a base. It's a weak base. Well, actually it's relatively strong, but it's not as strong. But anyway, NH3 plus water, and then you're going to get NH4 plus ammonium plus OH minus. Alright, so we did all the work here. And then again, we know the Kb, right? Since Kb is same as Ka, you can sort of see that, and we start with the same initial concentration as well for both of them. Yeah, so we could assume that. Okay, well, it's the same. So let's solve for x and assume that x is small, and we do our proof up there is less than 5%. So x is equals to, once again, 0.00020785. And then, since the x is OH concentration, so from that, we could take a negative log of that to get POH. And you see, since the concentration of H3O plus right here is same as the OH concentration here, we know that the pH and the POH value is going to be the same. And the pH is just and of course, we can also say that the pH here is going to be same as the POH here. 1.3, 1.3, and then of course, since we know that POH and pH are similar, those two parts, we just have to sort of switch the answer. So I hope that helps, and I don't have anything entertaining on my mind right now. I just know that I don't know, maybe next video.